Hi folks, welcome to 10.5 Polar Coordinates. So in this section we're going to take a look at a new kind of graphing, all right? And we're going to start with what we know. So what we know is here on the left, and this type of graph is called a rectangular coordinate or grid. And what we know about rectangular coordinates is that we have two numbers in parentheses, that the first number tells us how far we go side to side. So the 2 tells us we go 2 to the right, 0 means 0, -3 means 3 to the left, and -1.5 means 1.5 to the left. And then we know that there's a second number, so this is the 3, and that tells us that we go 3 units up. This 0 tells us we stay, and this -2.5 tells us we go down 2.5, and this 1 tells us that we go up 1. And that kind of graphing is very familiar to us. And what we're going to learn in this section is something called polar coordinates. And with polar coordinates, we have a different kind of system. So it has a pole, that is this right here. And then it has angles that go around. And this time when we graph, the first number tells us, so this 2 and that 3 and that -2, that tells us how many circles we go out. And the second number, this angle, so pi over 6, 7 pi over 4, and pi, that actually tells me which direction to go out in that circle. So for example, this one right here, I'm going to go to pi over 6, and then from the center I count out 2 circles, and that's how I end up at 2 comma pi over 6. At this point in the green down here, I have 3 comma 7 pi over 4. So I know that I'm going to 7 pi over 4, and then I'm counting out 3 circles, which is how I get to here. And for this purple one, we have 2 comma pi. That means I'm going to go to pi, and I'm going to count out 2 circles, and that's where I am. And so that's a short of how we use polar coordinates, okay? So we're going to start with graphing polar coordinates, and we're going to go through 2 examples where we just practice graphing some points. So let's take a look at example 1. Example 1, we're going to graph 3 points, A, B, and C. So let's say that we're going to graph point A in blue, that we're going to graph point B in pink, and that we're going to graph point C in the green. All right, so let's start off with 3 comma pi over 4. So I'm going to go to pi over 4, which is here, and then from my center, I'm going to count out 1, 2, 3 circles, and that is my point A. Now let's try point B. I'm going to find pi over 2, which is here, and from the center, I'm going to count out 1, 2 circles, and that is point B. And the last point, let's go to 4 comma 4 pi over 3. So I'm going to go to 4 pi over 3, which is over here, and from the center, I'm going to count out 1, 2, 3, 4 circles, and that's point C. And that's how you graph a polar coordinate. It's not super hard, but you just have to make sure that you do it in the right order. All right, let's try these other 3 points. So we'll do point D in orange. We'll do point E in this light purple, and we will do point F in this green. All right, so let's start with point D. So I'm going to go to 9 pi over 4. Now you'll notice on the unit circle there's no 9 pi over 4. So that means I have to keep counting until I get to 9 pi over 4. So let's see, I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So this is really the same as 9 pi over 4, okay? So I go to 9 pi over 4 and I'm going to count out 3 circles, and that's my point D. All right, let's find point E. I'm going to go to pi over 2, which is on my unit circle, but instead of counting 2 points up, I'm going to count 2 points down. So that's what that negative sign means. I'm going to count in the opposite direction. And so this point is my point E. All right, let's find our point F. So I have 4 comma negative 2 pi over 3. So I'm going to go start here, and I'm going to count in the opposite direction because it's a negative 2 pi over 3. So that will get me to here, and then I want to go 4 units along that direction. So 1, 2, 3, 4. Okay, and that is my point F. Now, one thing I want us to notice before we move on is that my point C from the first question is the same point as my point F in the second question, okay? So that's something different about polar coordinates, that you can have more than one name for the same point, all right? So we'll get a chance to practice that in our next couple examples, but keep that in mind, there's more than one name for any given point. All right. So now we're going to take a look at converting between polar and rectangular coordinates. So the relationship between polar and rectangular coordinates is as follows, that if you have a rectangular coordinate in xy and polar coordinates are written r comma theta, then you can convert between the two using one of two formulas. If you have the polar and you want to get rectangular, you're going to use this first one, okay? So this is polar going to rectangular. Now on the flip side, if you have the rectangular and you want to go to polar, then you're going to use this other set of equations, okay? So, as usual, let's practice these to kind of get the hang of the formula. So we're going to start with example 3. It says convert 3 comma pi over 4 into rectangular coordinates. So I have to use that first set of equations, okay? So if I want to find x, I need to do x equals r cosine theta, and y is going to be r sine theta. Well, if this is in polar, then r is 3, and theta is pi over 4. So I'm going to plug in 3 cosine of pi over 4, and this is going to equal 3 sine of pi over 4. Now for my final answer, I want to make sure that I've used my coordinate. So this is going to be 3 times root 2 over 2, or 3 root 2 over 2. And my y coordinate is actually going to be the same because the x and y coordinate for pi over 2 are equal. And so I'm going to want to write my final answer as 3 root 2 over 2, comma, 3 root 2 over 2. And so we've got our x and our y, which means we have this in rectangular form. All right, let's do example number 4. So example number 4 has rectangular coordinates, and they want us to convert it into polar coordinates. And then we're going to find 2 other pairs of polar coordinates that describe the same point. So this is like that practice for what is another name for that point, okay? So to start, I'm going to sketch a quick graph so I know what quadrant my answer is going to be in. If I go -1 and up √3, I end up in quadrant 2. Okay? All right, so let's use those formulas. R squared equals x squared plus y squared. That means my radius squared equals -1 squared plus √3 squared, and r squared will equal 4. That means my r is going to be 2. Okay? Now let's take a look at how to find our theta. So to find our theta, we're going to find arctan of y over x. And theta will equal arctan of √3 over 1, but it's negative because it's in the second quadrant. And so I need to find the angle in the second quadrant that matches that coordinate. And when I do that, I'm going to end up with 2 pi over 3. So one possible coordinate for this is going to be 2, 2 pi over 3. Now we need to come up with at least 2 other pairs that have the same coordinate. So one possible option could be that I actually go to 5 pi over 3. So I would go in let's pick a different color. So for this one, I would actually go in this direction, but then I would count backwards 2 to end up at that same point. So -2, 5 pi over 3. Another possible way I could write this is I could just keep the 2 the same and just go around the unit circle one more time. So let's see what that is. 2 pi over 3 plus another 2 pi or 6 pi over 3 would give us 2, 8 pi over 3 would be another name for the same point. And this one is just one more time around the unit circle. Okay? So that's where we're going to stop this video, the first part of 10.5. And when we come back, what we're going to do is now we're going to figure out how to convert equations from rectangular to polar and from polar to rectangular. All right, folks, I'll see you back here for the second video in 10.5.